In fiscal year 2016, INL received 30 patents and 2 copyright assertions. Here's a look at just a few of these important contributions. Current techniques for measuring thermophysical properties, particularly thermal conductivity, in high-temperature in-pile applications are slow, expensive, and inaccurate. Thermal conductivity is one of the most important properties for predicting nuclear fuel and material performance. The hot wire needle probe provides a better method for gathering real-time thermal conductivity measurements of fuels inside a reactor without the added cost and time or data quality reductions. This invention is credited to Keith Conde, Joy Rempe, Daryl Knudsen, Joshua Daw, Stephen Wilkins, Brandon Fox, and Heng Ban. Measuring a battery's impedance allows for control and diagnosis of battery performance. Although effective, the existing, well-established technique uses a series approach, which makes it time-consuming. John Christopherson, Chet Motlock, John Morrison, and William Morrison invented a single measurement parallel approach that allows for real-time acquisition of battery impedance over a specific frequency range without a significant loss of accuracy. There are many applications in which it is desired to detect the presence and concentration of harmful substances in a fluid. One example is monitoring for microbial pathogens in a source of drinking water, such as a lake. This patent describes a portable, automated, accurate, and repeatable pathogen concentration system that provides detectable concentrations of these pathogens in an accurate and repeatable fashion. The patent was awarded to Michael Carpenter, Lyle Roybal, Alan Lindquist, and Vincente Gallardo. Uncontrolled charge and discharge pulses can damage electrochemical battery cells, increasing excess heat and reducing cell performance and safety. David Jamison's patented method is configured to detect charge and discharge pulse transition rates of systems coupled to electrochemical cells. The pulse transition rate is then adjusted before it reaches the battery, sufficient to reduce degradation caused by transitions greater than a determined rate. Wireless services in harsh and hostile environments must overcome challenges such as intentional jamming and unintentional interference. Known for their robustness, spread spectrum systems extend information across more bandwidth than is required by the data rate. Multi-carrier spread spectrum is a particular form of spread spectrum designed to be resistant to narrow or partial band interference. This invention uses filter bank techniques to generate and detect multi-carrier spread spectrum signals that can carry information at a very low power level distributed over the frequency spectrum. The signal transmission is kept at or below the noise level of other signals, leading to a low probability of detection and interception. This invention is credited to Hussein Maradi, Harut Farhang, and Carl Kuchi. Extremophilic microbes live and thrive under conditions such as acidic or alkaline surroundings and boiling or freezing temperatures. They can be found in features such as Yellowstone National Park hot pots or the deep ocean thermal vents, glaciers, salt flats, and radioactive environments. Yet qualities for extreme survival are what make these microbes useful for turning biomass into biofuel. Current biofuel production processes require elevated temperatures and acidic conditions for extended periods of time. This patent describes a method to modify proteins in a microbe that help them withstand extreme environments and be of use in extreme industrial processes. This is one of multiple patents awarded to Vicki Thompson, David Reed, William Apel, David Thompson, and Jeffrey Lacey. Decreasing water supplies throughout much of the industrialized world have necessitated new methods and systems for utilizing water that contains contaminants or impurities. Traditional purification methods include thermal flash evaporation and reverse osmosis. Forward osmosis circumvents several of the deficiencies of reverse osmosis by using a draw solution with a greater osmotic pressure than the feed liquid. The concentrated solution pulls the water through the membrane, leaving the contaminants behind, and the water can be extracted from the solution with low-grade heat. Aaron Wilson and Christopher Orm were awarded this patent, which relates to the methods and draw solutions for treating a liquid using a switchable polarity solvent. The Integrated Waste Screening System, or IWSS technology, can efficiently assess the nearly 40 million tons of drilling waste generated annually by the drilling and fracking of oil and gas wells. Wells can produce significant amounts of technologically enhanced, naturally occurring radioactive material that must be characterized, segregated, and disposed of properly. Currently, the industry uses a limited and costly sampling and analysis method. IWSS could fix all that by providing an immediate on-site analysis and segregation of bulk waste material. It provides a cost-effective approach to characterization and segregation of waste, as well as documentation and certification that the waste disposal process is monitored and that the waste is being disposed of safely. The copyright was awarded to Lyle Roybal and Douglas Akers.